Hello, Algebra 2 students. Today we will be doing 7.6 notes, solve exponential and logarithmic equations. There are several properties of logarithmic and exponential equations that will help you solve it. The first one of these is called the property of equality for exponential equations. It says, if b is a positive number other than 1, then b to the x is equal to b to the y. If and only if x equals y. We are going to, before we do the problem, let's look at an example, just a numerical example. So if you have something like this, 3 to the x is equal to 3 to the 5th. Since the bases are equal, since these two numbers are equal, then their exponents are equal. So that's what it says. And vice versa. If x equals 5, then 3 to the x is equal to 3 to the 5th. All right, doing an example. So we have 7 to the 3x minus 4 equals 7 to the 5th power. When the bases are equal, and only when the bases are equal, can you set the exponents equal to each other? And since the bases are both 7, you can do that. Then you add 4 to both sides. 3x is equal to 9, and then divide both sides by 3. X equals 3. That one was simple. What if the bases aren't identical? Well, then you have to get bases to be the same. And I mentioned this earlier on in this chapter. So you have 3 to the 3x minus 8. Here you have 81. Well, that's not the same base as a base of 3. But if you remember your powers of 3's, we know that 3 to the 4th power, 3 times 3 times 3 times 3, 3 times 3 times 3 times 3, yes, is equal to 81. So we can write 81 as 3 to the 4th. That's going to be raised to the 13 minus 3x power. And now you can set the exponents equal to each other. You can simplify first the right side. So you can distribute that 4. So it'd be 3 to the 52 minus 12x. And now you can set the exponents equal to each other. So 3x minus 8 equals 52 minus 12x. And what we want to do is we can add 12x to both sides. So that's 15x minus 8 equals 52. Add 8 to both sides. 15x equals 60. Divide by 15. X equals 4. And our last one in that bunch, so we have 4 to the x power is equal to 1/2 to the x minus 3 power. So this one, you're going to have to do several things. You can just leave, you can call 4 to the x as 2 squared to the x power. And remember, 1/2 is the reciprocal of 2 to the of 2's, but then you have to bring that into bring the 2 up to the numerator and sure you're going to have a negative exponent raised to the x minus 3. And now you can set these equal to each other. Oops. Because the bases are identical. So we have 2x equals negative 1 times x minus 3. So that's 2x equals negative 1x plus 3. Add 1x to both sides. 3x equals 3. Divide by 3. X equals 1. Right. So that's how to solve exponential equations when the bases aren't necessarily the same. How do you solve for a power if the bases cannot be made the same? Because sometimes you can't make the bases identical. You just can't. And when that happens, you must follow these 4 steps. Step number 1, isolate the exponent equation. Step 2, take the log base b of each side. And here I'm just letting you know that, remember, b means base. Okay, then from the last section, from section 7.5, you're going to use the change of base. So you can use your phone calculator or a regular calculator, whatever you prefer. And so step 4, use calculator, phone, or scientific. You don't need a fancy calculator to use change of base. You just need a simple scientific calculator that has the log button, and that's all you need. So here's a case where you can't take the number 5 and use 2 as a base. You can never get 5 to become the base of 2. It's just not possible. So when that's the case, we want to get the exponent expression by itself. So it is 2 to the x is by itself. So step 1 is done for us. Step 2, we're going to take the log base b of each side. So log base b, the base is 2 of that 2x, 2 to the x, sorry, and you take the log base b, and the base is 2 of 5. And so here's what happens on the left side, which is really cool. We learned that when you have, it's a specific property of logs, when these numbers are identical, so when the 2 and 2 are identical, or whatever, 5, 5, 8, 8, that all of this cancels, and you're left with just x. And on the right side, you're going to use change of base. So change of base from section 7.5, that's log 5 divided by log 2. And you want to use your calculator. So if you're going to use your phone, you want to hit 5 and then log and then get an answer. And then you do the same thing for the bottom, hit 2 and then log, get an answer, and then you're dividing the two numbers. So you end up getting, and you should try this, x is about 2.3219. Okay. For the next one, add 25 to both sides because you want to get the 5 to the x alone. So you have 5 to the x equals 65. You can't divide both sides by 5 because 5 is raised to an exponent, but you can take the log base 5 of both sides. So take log base 5, because 5 is the base in 5 to the x, of the left side of the equation, and then do the same thing to the right side of the equation. Okay, that all cancels out, and you're left with just x. And on the right side, change of base, so you do log 65 divided by log 5. And then, of course, you're going to do all that stuff in your calculator, and x is about 2.5937. Okay, and the last one has a base e involved. So the first thing you want to do is add 7 to both sides, move the constant over. So you have 4e to the negative 0.03x equals 20. Then divide both sides by 4. E to the negative 0.3x equals 5. Now you can't get 5 and e to be the same base, but you can take the log base e of both sides. So natural log, because remember, natural log has a base e. So take the natural log base e of this left side, which is e to the negative 0.3x, and do the same thing on the right side. Take the natural log base e of 5. Okay, and so this cancels everything except the negative 0.3x. So we have negative 0.3x on the left side, And on the right, you're going to use change of base. So you're going to have ln of 5 divided by ln of e. Right, so this one's a little trickier. So what you want to do is, what I did actually was, I did this a little bit differently. Okay, hold on, let me see. I wrote too big, one thing, so I'm going to erase this part right here. And then I want to show you something. You don't want to use change of base for a natural log, and I'm going to show you why here. So the left side, I should have left it alone. So that was negative 0.3x. But this ln base e, this is the same thing. It's just understood that it's, so all you're going to do in your calculator is punch in 5 and then hit the ln button, and it will give you some decimal number. It gave me 1.6094. And then their last step is to divide both sides by negative 0.3. And that gives you x is about negative 5.3647. And that's how you do exponential equations when the bases cannot be made the same. Okay, so far all we've talked about has been solving exponential equations. What if we are asked to solve logarithmic equations? So here's the property of equality for logarithmic equations. If b is a positive number other than 1, just like exponential equations, then log base b of x is equal to log base b of y if and only if x equals y. So again, if you pay attention here, these are identical. And when those are identical, you can set x and y must be true, or x equals y must be true, sorry. So let's look at these problems. So looking at problem A, notice what is alike is that this portion is alike. I'm just going to circle it right now temporarily. When you know those two are alike, then you can just set 5x plus 9 equal to 6x. Pretty simple. And then you just solve the equation like you normally would solve any linear equation. So subtract 5x, 9 equals x. And we should check our answer. So for this particular one, it's not that crucial to check it because we have, actually this is going to be crucial to check. For these, you should always check. So I'm not even going to take a shortcut on this one. So we are going to check the equation. I'm going to check it right here. So I don't have much room in between A and B. So I'm going to replace 9 back into my x. So log base 5. 5 times 9 is 45 plus 9. And do the same thing on the right side, equals log base 5. 6 times 9 is 54. So log base 5, 54 equals log base 5, 54. That's true. That's a true statement. So this does check. That is an answer. Okay, now let's do B. So this is identical to that. Therefore, you can set the 5x plus 18 equal to 7x minus 8. Subtract 5x. You have 18 equals 2x minus 8. Add 8 to both sides. 26 equals 2x. Divide by 2. X equals 13. Oops, I did not mean to circle it because we need to check it first. So let's check it. So I'm going to check it for this particular one. I guess I can check it down here. Okay, so natural log 5 times 13 is 65 plus 18. Now, where am I checking it? I'm checking this answer always back into your original equation. So wherever you see an x, replace it with 13. equals natural log 7 times 13 is 91 minus 8. So 65 plus 18 is 83. And here 91 minus 8 is 83. That checks because the left side is exactly identical to the right side. So this is the correct answer. Okay, let's do one more out of that bunch. So we know this is identical to that. Therefore, let's set 3x minus 10 equal to 14 minus 5x. Add 5x. We have 8x minus 10 equals 14. Add 10 to both sides. I'm going to skip that step because I'm running out of room. Divide by 8. X equals 3. Now we are going to check our answer. So I'm going to check. I guess I can check right here. We have a little bit more room. So log base 6, 3 times 3, which is 9, minus 10, equals log base 6, 14 minus 5 times 3. Log base 6 of negative 1 is equal to log base 6 negative 1. Here is why this doesn't work. Just because the left side is identical to the right doesn't mean anything. I should have been more clear. Both of those numbers must be negative or must be positive. Here's what you can't do. You can try using change of base and say, hey, what's log negative 1 divided by log 6? Log negative 1 divided by log 6. This top part will give you an error message because there is no such thing as the log of a negative number. So even though the left side is equal to the right side, it's not defined. So this part right here is undefined. So undefined. It gives you an error message. So this is a no solution. This is an extraneous solution. So this is an example of a no solution. So I should have been more clear. The only reasons why A, B, and C worked were because the numbers were positive. So when you plugged back, you got like natural log of 83 or log base 554. So you got positive numbers, and that's why it worked. Okay, now going to the next page. How do you solve for a log that is only on one side of the equation? And so here's what you do. So step number 1. Condense the logs. Step 2, get the log by itself. Step 3 is such a crucial step. So rewrite the equation in exponential form. Notice I'm going to all caps this. I would highly recommend using these notes on your test for this particular section because there's so many steps involved. Step 4, solve the equation. And lastly, when you're dealing with logs, you check your answers. So check for extraneous solutions. All right, and it's a big hint. If I say solve the equation and I write afterwards check for extraneous solutions, you should check for extraneous solutions. So let's look at each of our steps. Step 1, condense the logs. Well, the logs are already condensed. There's only the word log appearing once on either side of the equation. So step 1 is done. Step 2, get the log by itself. The log is by itself. Step 3, rewrite the equation in exponential form. So here we'll start with step 3. So going back to what we remember, this is a base. When I read it as log base 2, this is your exponent, always on the opposite side of the log. And once you know that, you can write it in exponential form. So 2 to the 5th power equals x minus 6. And that's step 3. So we did step 3 first, and then step 4, we can solve the equation. So 2 to the 5th is 32, equals x minus 6. Add 6 to both sides. So I'm doing steps 4 and 5 here. So that's 38 equals x. And then you want to check your answer. So let's check to make sure that the logs are positive. So log base 2, x is 38. So 38 minus 6 is 32. And that is true because both 32 and 2 are both positive numbers. So that does check. 2 to the 5th power does equal 32. Because that's how you'd write that. Base 2, base, exponent. And we know 2 to the 5th does equal 32. That checks. 32 equals 32. Great. So our answer is x equals 38. Okay, our next one, the logs are already condensed. You only see the word log once. We need to get the log by itself. So the first thing we want to do is divide both sides by 3. So we get log base 4 of 8x equals 2. And now we can write it in exponential form. So 4 is our base, raised to the 2 power equals 8x. 4 to the 2nd power is 16. Divide by 8. X equals 2. And then always check. So check 3 times log base 4, 8 times 2 is 16, equals 6. Divide by 3. Log base 4 of 16 equals 2. Write into exponential form. 4 is your base. Is 4 to the 2nd power equal to 16? It is. 16 equals 16. So it checks. And this is your answer. Okay, and our last one. Notice step 1 you must do because you have logs appearing multiple words or multiple times. You can only have the word log appear once on any side of the equation. So we want to condense it. Because we see the plus sign here, we want to use the product property. So we would write that as log base 4 x times x plus 12. I put the x in front because it's a single letter, equals 3. So now we only have log appearing once. So step 1 is done. Step 2, the log stuff is by itself, so that's good. Step 3, we're going to rewrite the equation in exponential form. So this is our base. This is your exponent. It's all you need, those two things. So write base raised to an exponent gives you the answer. So x times x plus 12. Not the answer, but the other part of your equation. So 4 times 4 times 4 is 64 equals x squared plus 12x. Okay, and I want to get the right side equal to, or I'm sorry, the left side equal to 0. So I'm going to subtract 64. When you see a x squared term, you know you want to attempt to factor this. So I'm going to make a x factor chart here. So b is positive 12, goes down here. A times c is 1 times negative 64. Now find two numbers that multiply give you negative 64, added give you 12, and it's a positive 16 and a negative 4. So we have 0 equals x plus 16 times x minus 4. Now set each of these equal to 0. So your answers are x equals negative 16 and x equals positive 4. And for this particular one, I don't have room, but you should figure out which one will not check. And the one that won't check is this one, because if you replace it back here, you get negative 16 plus 12, which is negative 4, and you can't have the log, take a log of a negative number. So this is extraneous. This one works. I just don't have room to do it. So, but you can go back and check it. 4 plus 12 is 16, and then the other one's going to be 4. They're both positive, so it checks beautifully. Okay, and now we are going to do at least one of these word problems, so maybe both. So the Newton's law of cooling uses exponential equation. So that's a real life application. This important application of exponential equation states that for a cooling substance with initial temperature T sub 0, so the initial temperature is known as T sub 0, the temperature T after T minutes can be modeled by the following equation. So the capital T by itself is the ending temperature. The one with the little 0 is the beginning temperature. And this is known as the room temperature. Makes sense. T sub R, R for surrounding temperature or room temperature. And R, little r, is the cooling rate. So that little r is a cooling rate. So as long as you know what everything is, all you do is you plug in the numbers into the formula and solve the equation. Let's use that equation right here to do the problem example 5. All right, so hot chocolate has been heated to 90 degrees Celsius. Hot chocolate that has been heated to 90 degrees Celsius is poured into a mug and placed on a table in a room with a temperature of 20 degrees Celsius. So the room temperature is 20 degrees Celsius. So 20 degrees Celsius is the room temperature. Little r is a cooling rate. It's already given to you, so you don't have to worry which one is which. When the time T is measured in minutes, how long will it take for the hot chocolate to cool to a temperature of 30 degrees Celsius? So this is the ending temperature. So 30 degrees Celsius is going to be T. We don't know what little t is because it's asking us how long. But we do know that the initial temperature is 90 degrees. So this. But notice you've identified everything. At this point, you just need to plug it into your formula. So the left side is the ending temperature. So it's 30. Don't worry about putting degrees symbols. Equals the initial temperature, which is 90, minus the room temperature, which is 20. Close your parentheses. Put the letter E here. The cooling rate, it's always going to be, this number is always going to, E is going to always be raised first to that negative power. So negative 0.145 times little t, because we're asked to solve for t, plus the room temperature again, which is 20. Okay, so now we've plugged in everything. We just now need to solve for the equation. So the goal is to get the E stuff by itself. First thing you can do is subtract the stuff in parentheses. So 30 equals 70 e to the negative 0.145 t plus 20. Now you want to move the plus 20 junk to the other side because you have to get the e stuff alone. So 10 equals 70 e to the negative 0.145 t. Divide both sides by 70 because you want the e stuff by itself. And that, the zeros cancel, and you're left with 1/7. So at this point, I'm going to move over here just so I have room. So we have 1/7 equals e to the negative 0.145 t. And now, since you're dealing with base e, you want to take the natural log of both sides. So the natural log 1 over 7 equals natural log, and remember this is base e. I'm not going to put on the left side, but here I will just because you actually see the letter e. So e to the negative 0.145 t. On the left side you don't need to because you have it's just ln of 1/7. Okay, so this stuff cancels on the right side, and you're left with just negative 0.145 t. And on the left side, what I did was I just did, I figured out I did 1/7 as a decimal. So I did 1 divided by 7 and then took the natural log of it. That's what I did. So I got, I just did ln of 1/7. And I got negative, on this side, I got negative 1.9459. On this side, I just had negative 0.145 t. Divide both sides by negative 0.145. And a negative divided by negative is a positive, and it better be because time is not negative. And so that cancels, you're left with t, and I got t is about 13.42. So rounded to the nearest minute, I guess, it'd be 13 minutes. About 13 minutes is how long it'll take the hot chocolate to cool to 30 degrees Celsius. Okay, and we will do one more using Newton's law of cooling. A detective is called to the scene of a crime where a dead body has just been found. She arrives on the scene at 10:23 p.m. Immediately, the temperature of the body is taken and is found to be 80 degrees Fahrenheit. So that is the ending temperature. So you need to identify the correct things. The detective checks the thermostat and finds that the room has been kept at a constant 68 degrees Fahrenheit. So 68 degrees Fahrenheit is the room temperature. The next day, the detective is asked by another investigator, "What time did our victim die?" Assuming that the victim's body temperature was normal, and normal means 98.6, so this was our initial temperature. So this is T sub 0 prior to death and cooled at a rate of, so this is definitely R, but just remember it's negative. So cooled at a rate, it's Newton's law of cooling. So even though that's the rate, you still have that negative in front. So R is going to be positive, but you make sure you have that negative sign in front. So what's the answer to the question? So what time should you die? So again, we're going to solve for T. So what time? So what is little t? Right. So let's do this information. So our final temperature is 80 degrees equals our initial temperature is 98.6 minus the room temperature, which is 68, close parentheses, e to the negative, and the cooling rate is 0.134 times little t plus the room temperature again. Okay, we're going to repeat the process that we did on the previous problem. So do the stuff in parentheses first. So 98.6 minus 68 is 30.6. I'm sorry, we need a parentheses after that because I'm just subtracting the stuff in parentheses. So that gives me 30.6 e to the negative 0.134t plus 68. I subtract 68 on both sides. The same process as the hot chocolate one, just different numbers. So 12 equals 30.6 e to the negative 0.134t. Divide by 30.6. 12 divided by 30.6. Now, I just left it like that, but you don't have to. You can actually do 12 divided by 30.6, and a lot of students like to do that, and I might for this one. So I'm going to go ahead and actually do what 12 divided by 30.6 is. So 12 divided by 30.6 is point, and I'm going to use several decimal places, 0.392157 to be as precise as possible. I mean, this is forensics here. So I could have used more decimal places, but I'm going to leave it at that. And the right side is e to the negative 0.134t. Okay, running out of room. So now I want to take the natural log of both sides. So natural log 0.392157 equals natural log negative 0.134t. Remember that's, oops, forgot the e. Yikes. Okay, this is not good. So I'm going to erase that part and write it a little bit nicer. So natural log e to the negative 0.134t. Remember, that's just a base of e, so the e's cancel. Okay. And the other stuff, those stuff on the left side, I'm going to put it in a calculator. So I'm just using my phone right now, and I'm going to enter 0.392157, and then I'm going to hit the LN button. So remember, landscape, third row, fifth button is LN, and I get negative 0.9360. So this side is negative 0.9360, and this side is negative 0.134 T. Divide both sides by negative 0.134. T equals 6.9857. So we're just going to round that to 7 hours. So now, since the victim died at 10:23 p.m., work backwards 7 hours from that was, so subtract 7 hours. So the victim died at 3:23 p.m. And that is an application of Newton's law of cooling as well. And these are your notes for today. Have a great day, Algebra 2 students.